Now, in this video, we are going to take up one more problem on projections of lines, the problem number 59. How to solve this problem, how to analyze this problem in 3D and also by how to solve by using the sketchbook. So, problem number 59, a line capital PQ measures 80 mm in length. The point P is above HP and in front of VP by 20 mm and 30 mm respectively. The distance between the end projectors is 50 mm. The line is inclined to VP by 30 degrees. Draw the projections of the line and specify its true inclinations with HP. So as he has given, the point P is above HP and in front of VP by 20 and 30 mm respectively. So when you look from the front view, we can see the distance 20 mm above HP. And when you look from the front view, it is projected onto the vertical plane. So you're going to get this 20 mm above HP. So you mark this point as capital P and here this as capital P here. And you mark this as small p dash because it is the front view. Similarly, when you look from the top view, we can see the distance 30 mm in front of VP. So in front of VP, when it is projected, it will be projected onto the horizontal plane. So you're going to get it as small p here and also capital P. So once you get this, so you're going to have a projector P here in the vertical plane and also in the horizontal plane. Then the line capital PQ measures 80 mm in length, which is inclined to VP at 30 degrees. So he has given the true length and the true inclination in the top view. So with small p as center, taking the radius, with small p as center, so you draw a line which is inclined at 30 degrees to VP for a distance of 80 mm. So once you get this, so you're going to get the true length in the top view. Once you get the true length in the top view, so you will going to get the locus of Q in the top view. So you mark this point as Q2 and join P and Q2 with little bit thicker than the XY line. So we know that this is the true length in HP. So obviously that line should be parallel to HP. So you can see both capital P and Q2, which will be above HP by 20 mm. And also when you look from the front view, that image will going to fall on the vertical plane, which you can see that P dash and Q2 dash. So how we are projecting that? When you are projecting from here, so it will goes to this and then from here it will comes to this. So you're going to get P dash Q2 dash, which is above HP by 20 mm. So that means P dash Q2 dash is the line which is parallel to HP. So you're getting the true length in HP. So we got the true length. Then we know that the distance between the end projectors is 50 mm. So we have projector projector P in the front view. So from here you take 50 and draw a vertical line. Similarly, when you look from the top view, you can see the end projector distance of 50. So from here you mark 50 mm and draw a line here. So since this line will going to cut the locus of Q in the top view, so obviously you will going to get small q, then join P and Q with a dark line. So this becomes the top view. Now we have the top view and we have the end projector here. So our main aim is to find out the top view, front view first. To find out the front view, I need to consider the true length in the top view, because first I need to find out the locus. To find out the locus, first I should have the front view now. So to do that, we know that we cannot take the top view, because if you take the top view, then we have to find out the true length. But we know the true length. That is also possible. But as we know that here we have the true length in the top view. So once you have the true length in the top view, so what I can do is with P as center, taking the radius of PQ2, which is in line in space, you rotate it till what? Such that till this image Q will going to cut on this end projector line. So you rotate in such a manner that this Q, you are going to get the Q dash. That Q2 will going to, this Q will going to come and touches the end projector line of 50 mm in the front view. So when you are doing like this, what happens? The image in the front view is also getting rotated in the vertical plane as we look from the front view. So what happens? We know that, in other words, when you have the true length in the top view, we know that this is the true length in the top view. So obviously that line should be parallel to HP. So that means in the front view that line should be parallel. P dash is above HP by 20 mm. So obviously Q2 dash should also be above HP by 20 mm. So therefore you are projecting from here and also then from here, so that you are going to get Q2 dash here. So this will going to be the front view. But actually Q2 dash is not above HP by 20 mm, but instead this Q2 dash should lie on this end projector line. So to do that with P dash as center, taking the radius of P dash Q2 dash, you draw an arc such that it will going to cut on this end projector. So you mark this point as Q dash, then join P dash Q dash with a dark line. So now we got the locus of Q in the front view. Once you get the locus of Q in the front view, now we need to find out the true length in the front view. So to find the true length in the front view, so with P as center, taking the radius of PQ, you rotate it such that you make it that Q should be parallel to VP. That means Q1 and P both are in front of VP by 30 mm. So when you're doing that, so capital PQ1 is the line which will going to be in true length because both capital P and capital Q1 are in front of VP by 30 mm. So now the line is parallel to VP. So when it is projected, it will be projected onto P dash Q1 dash. Here P dash Q1 dash is the line which will going to be in the true length. So join P dash and Q1 dash with little bit thicker than the XY line. As we know that this is the true length, so you mark this as Q1 and Q1 dash, capital Q1, and this as capital P. So this is how you will be able to analyze this problem. But when you are doing it in on the plane, so when you look from the top view, so P as center, taking the radius of PQ, you make it rotate it such that both P and Q1 are in front of VP by 30 mm. So then once this line is parallel to VP, so you will going to get the true length in VP. So from Q1, you draw a vertical projector till here. And then again, you draw a vertical projector from this point till to cut the locus of Q in the front view. So you're going to get this as Q1 dash. As we know that this top view line is parallel to XY, so you're getting the true length. You mark this as capital Q1 and P. So this is how you will be able to analyze this problem in 3D. So when you are doing it in stepwise, so first we will going to take up the true length which is given, and then once you get this, you got the locus of Q. So once you get the locus of Q, you have the distance between the end projectors, which is 50 mm. And once you project this, you will going to get the top view, that is PQ. So here with P as center, taking the radius of PQ1, you rotate it and make it parallel. So once you do that, as we know that we have the true length, which is 80 mm in length. Obviously, you can do the true length is same in both in front view and top view. So obviously with P dash as center, then you cut a radius on this locus, so this end projector, so that you will going to get Q1 dash. As we know that this line is parallel to VP, so you are getting the true length. So you have got capital P and capital Q. Then join P dash Q1 dash with a little bit thicker than the XY line. This is also one method wherein, because since you know the true length, you can do it. But otherwise what we can do is you just project this to the front view. You take the true length line, which is PQ, which is PQ2. From here you draw a projector till to the here. Then that will go to become P dash Q2 dash. Then with this P dash as center, you're taking the radius, you rotate it and make it to such that it will going to cut on this end projector. So you will going to get the locus of Q and join P dash Q dash. So this is also one more method. So, but here I have shown one more, here I have explained this 3D analysis in that method. But to show this in the other method, we have shown this is the another method in which you can be able to do it. So that is what we, but here what I have shown here is the one which we have been rotating and make it parallel, and then it is projected so that you will go to get this true length line. So this is how you will be able to solve this problem in 3D analysis and stepwise in first step. Now we will go for the finding out the true length in the top view now. So to do that, once you get the true length in the, once you get the, once you get the locus, you have got the front view. So from here, P dash Q1, Q dash, you rotate it, make it parallel. Then when it is projected, you will going to get this Q2 here. So this is also one more method. So now we are going to try to solve this problem by using the sketchbook. So to do that, so first we are going to draw the XY line and you mark VP and HP. Then as we know that the P is above HP and in front of VP by 20 mm, 30 mm. So from XY line, you measure 20 mm and you draw a horizontal line. Similarly, from XY line, you measure 30 mm below XY line and draw a horizontal line. Consider any point and then draw a vertical line here, and you mark this point as small p dash and this as small p, and you mark this as capital P in bracket and capital P in bracket in the front and top view respectively. Then we have the true length is 80 mm length, and this is inclined to VP at 30 degrees. So from P, by using the protractor, you measure an angle of 30 degrees with respect to the horizontal and then draw an inclined line. Then as we know the distance is 80, by using the compass with P as center, taking a radius of 80, cut an arc on this 30 degree line. You mark this point as small q2, then draw a horizontal dash dot line, and you mark this as capital Q because he says then capital PQ is 80 mm long. So then you write this as the locus of Q. Then you measure the distance between the end projectors is 50. So from this end projector P, you measure the distance of 50 mm parallel to the XY line, and then draw one more vertical projector such that it will go to cut the locus of Q in the top view, and you mark this as small q. Then join capital P and Q with a dark line. Once you do that with P as n, then what we need to do? So now you extend this end projector line in the front view till to the front view. Then from P you measure, you take from Q2, you draw a vertical projector till to the locus of P in the front view, because PQ2 is the line which is parallel to HP. So obviously P dash Q2 dash is parallel to HP. So obviously PQ2 will be in true length. So you know that P dash is here. From Q2 you draw a vertical projector so that it will going to touches this the locus of P in the front view, so that both will going to be parallel. So this will going to become Q2 dash. By using the compass with P dash as center, taking the radius of P dash Q2 dash, you draw an arc such that it will going to cuts on the end projector line, so that you will going to get this point as Q dash. Then join P dash Q dash with a dark line, and this will going to be the front view. Then draw a dash dot line, so which will going to be the locus of Q. Then with P as center, taking the radius of PQ, you draw an arc such that you make it parallel to VP. So PQ1 will going to become parallel to VP. Then from Q1 draw a vertical projector till it cuts the locus of Q in the front view, and you mark this point as Q1 dash. Then join P dash Q1 dash with little bit thicker than the XY line. And as we know that this is the top view line is parallel to XY, so its corresponding front view will be in true length. So you mark this as capital Q here. Then you identify the angle theta here. Then by using the protractor, you measure from P dash as center using the protractor. You measure the true inclination line, which will be equal to theta. The value will going to be 37 degree when you are doing it in manual. When you are doing it in computer, it will going to be 36.83, and show all other dimensions as shown. So this is how you will be able to analyze and also solve the problem using the sketchbook. Thank you.